Am I audible, guys?
Yes, yes.
Yeah. So should we begin? Yeah. Okay. So yeah. So we're discussing about VCRS, right? So the part one we have discussed the basic working principle of VCRS and the components of VCRS and the working cycle of VCRS, right? So have you guys been through my video or the recorded session? It was shared in the group. Have you been through the part one because only Ravi Raj was present in the first part, I think. Naizil and Neeraj, you both were not present, I think. Guys, please speak up. Am I right?
Yes, I was there.
Okay. So let's continue with the second part of the discussion. So today we are going to discuss about the temperature and pressure of refrigerant at the particular component or the particular mounting of the VCRS cycle. Okay. So basically, the question is asked like, what is the temperature and pressure at the evaporator coil? So this is the most common question asked in the interview. Okay. So there are also chances that him or interviewer might ask that what is the pressure and temperature at condenser and what is the pressure and temperature at compressor and what is the pressure and temperature at thermostatic expansion valve. So today we are going to learn or discuss all the temperature and pressures at all the parts. Okay. So most important question is what is the temperature and pressure at evaporator coil? Okay. So this is the question. So is there anyone who knows what is the temperature and pressure at evaporator coil? How do you answer this question? Anyone? Yeah, Raviraj.
Sir, basically, this depend upon the which refrigerant we use in refrigerator, right?
Yeah, correct.
If we use R134A refrigerant,
Okay.
then the temperature of the evaporator coil is around the minus 18 degrees Celsius to 20 degrees Celsius for freezer department and vegetable compartment 4 degrees Celsius at 1 bar pressure.
Okay. Correct. So is there anyone who wants to add something to this, or is this completely right answer? Okay. So I will tell guys. So actually, as he said, the temperature and pressure depends on the type of refrigerant we are using, and there are many other parameters on which it depends. So, what are the other parameters on which it might depend, guys? Any idea? What might be the other parameters? Uh, Type of refrigerant is one of the parameter on which the temperature and pressure of the refrigerant depends. Okay, so there might be other parameters also. So do you guys know what are the other parameters? Anyone?
Latent heat,
Latent heat. Okay.
boiling point, and freezing point of refrigerant.
Okay. Boiling point and freezing point of the refrigerant that comes under the type of refrigerant only, no?
Okay. Okay.
Yeah. So other external parameters other than type of refrigerant. Hello. Okay. So guys, the other parameters which affect the temperature and pressure are ambient temperature, design, and some external forces. Okay. So these affect in the temperature and pressure very minutely. This does not bring
Okay.
any drastic change in temperature and pressure. The main factor on which the temperature and pressure depends is obviously the type of refrigerant used. These are also the parameters or factors which affect the pressure and temperature, but very minutely. So interviewer might ask this question, so please note it down. Okay. So are you clear on this? The factors which affect the temperature and pressure. So shall we move ahead? Okay. So guys, as he said, so the temperature and pressure mostly depends on type of refrigerant we are using. So for R134A at evaporator coil, basically in evaporator coil, there are two compartments, right? One is the freezer compartment and another is a vegetable compartment. So for freezer compartment, the temperature is around minus 18 degrees Celsius to minus 20 degrees Celsius, and for vegetable compartment it is up to 4 degrees Celsius, and the pressure on both side is up to 1 bar. So guys, when you tell the temperature and pressure, it is the approximate pressures, not exact. It is not an exact pressure and exact temperature. There might be 0.1% of error. There might be difference. It might be 1.1 1 bar pressure. It might be 1.12 bar pressure. So it is approximate pressures which are mentioned here. Okay. So when you're giving the answer, you need to mention the term called approximate. Okay. So these are not the exact values, these are the approximate values. So my next question is, guys, in evaporator coil, as Raviraj said, there is a freezer compartment and there is a vegetable compartment, right? So my question is, there is a different temperature in freezer compartment and there is a different temperature in vegetable compartment. So how is it possible to achieve two different temperatures, guys? Anyone? Guys, please speak up. Yeah, Raviraj, please go ahead.
I think the maintaining different temperature in a refrigerator can be achieved by using single compressor. This
Yeah,
concept is called as dual cooling.
yeah, that's dual cooling. Compressor is a single compressor only is used. So
Okay,
how do
this
you achieve the different temperatures? How do you set that different temperatures?
in this system, refrigerant is separated into two circuits.
Okay.
Each circuit with its own evaporator and temperature controller. So one circuit cools the refrigerator compartment, and while other cools the freezer compartment.
Okay. So this answer is partially right because the term circuit which you are mentioning is not actually correct. There are actually two evaporator coils. Okay. Basically, the cooling effect is taking in the evaporator coil, right? The
Yes,
ultimate goal is evaporator coil only. The freezing effect is or cooling effect is taking at the evaporator coil only, right? So there are
yes.
two different evaporator coils for freezing compartment
Sir,
and
okay.
for vegetable compartment.
So two types of particles and one hour the length is more than of another. Can be possible.
Sorry,
Varying the
your
length
voice is
and
not audible, Neeraj.
yeah,
Your
yeah,
voice is breaking. Can you please
yes.
come
I
again?
have a range problem. So I have range issue. That's why.
Yeah, okay. What were you saying, Neeraj?
So by changing the length of the evaporator coils, varying the length.
Okay, varying the length of the evaporator coils. So actually, varying the length of the evaporator coils that absorbs more heat because the main thing is that there are two evaporator coil, guys. For freezer department, there is a different evaporator coil, and for vegetable department, there is a different evaporator coil. So that's why there are two different temperatures being achieved there. Okay. So this is not only one evaporator coil which is giving a different temperature in freezer department and a different temperature at vegetable department. Okay. So there are two different evaporator coils. So the temperature parameter is set differently for freezer department and for vegetable department. Okay. This principle also works in our day-to-day life. In our household refrigerator also, there is a different temperature at defreeze and there is a different temperature for normal compartment, vegetable compartment, right? So actually there are two
Right.
different evaporator coils. That is not a single evaporator coil. Okay.
Yes.
So is it clear up till this?
Yeah.
Is it clear, guys, or is there any doubt up till this? Clear, right?
Clear.
Yeah, yeah,
Yes.
yeah. Okay. Uh, so next, after evaporator comes the compressor, right? So what is the pressure and temperature at compressor for R134A? Anyone? So at evaporator coil, it was 1 bar pressure, right? 1 bar pressure at the evaporator coil. So what happens when the vaporized vapor refrigerant is entered into the compressor? What happens in the compressor, guys? Actually, the vapor refrigerant is getting compressed, right? So there the pressure and temperature increases. Obviously, the 1 bar is increased into what is the pressure for R134A at compressor? Approximate pressure and temperature.
I think about 10 bar and 15 degrees centigrade temperature.
15 or 50? 1 pi or 50?
Temperature will
15,
be
15.
Okay. Yeah, Jitu, you were saying something?
yeah for temperature of evaporator will be around minus 18 degree, right? Celsius.
Yeah,
At the compressor.
minus 18 to minus 20 degrees Celsius, that is approximate for evaporator coil. That is for R134A at evaporator coil in the that is in the freezer department. And it is minus 18 degrees Celsius to minus 20 degrees Celsius at 1 bar pressure. And in vegetable component compartment, it is up to 4 degrees Celsius. Okay. So I am asking about compressor. So when the refrigerant enters into the compressor, the refrigerant is compressed there, and the pressure and temperature increases, right? So I am asking what is the temperature and pressure in the compressor for R134A, the refrigerant?
At compressor it will be around 50, temperature will be around 50 to uh, 80 degrees Celsius, I think.
Okay.
And pressure will be around 10 bar.
Okay. So actually, guys, in compressor for R134A refrigerant, the temperature is around 50 degrees Celsius. Raviraj, it is not 15, it is 50. It is up to 50
Okay.
degrees Celsius, and pressure is around 10 bars. It might vary also. It is around. I am telling around, approximate. It is not correct answer, or it is not 100% 10 bars. It might be 10.1, 10.12, or the temperature might be 51, 52, up to 50 degrees Celsius. Okay. So after
Okay.
compressor, what comes, guys? Which component? After passing from the compressor, where is the refrigerant going now?
Condenser.
Yeah, okay. So what is the pressure and temperature at condenser? Anyone?
Can you tell?
Yeah, sure. Uh, the pressure at compressor is 10 bars only, and the temperature is as you guys know, after passing from the compressor, it moves to the condenser, right? What happens in the condenser, guys? There is a high pressure and slightly low temperature of the vapor refrigerant, right? The pressure remains constant. That is the isobaric process happening there. There is a
Yes.
drop in temperature, slightly drop in temperature, right? So now the
Right.
pressure is 10 bars only, up to 10 bars only. Temperature is dropping here. Temperature is dropping. That's why the temperature is approximately 38 degrees Celsius here in the condenser. Okay. Are you guys following? Yeah, okay. So the pressure remains same here, that is 10 bars only, and there is a drop in temperature, that is up to 38 degrees Celsius. Okay. So after moving from condenser, where does the refrigerant flow, guys? Where does it go? Now the high pressure and slightly low temperature vapor refrigerant moves to,
Thermostatic expansion wall.
yeah, correct. It moves to
Right.
thermostatic expansion valve. What happens in thermostatic expansion valve, guys? If you know the working of thermostatic expansion valve, what happens there? Any idea? Guys, there is a sudden drop in temperature and pressure in the thermostatic expansion valve, right? Am I right or wrong? Because thermostatic expansion valve acts as an orifice there. Due to the sudden increase in area, there is a drop in pressure and temperature. So now, after passing from the thermostatic expansion valve, where is the refrigerant moving, guys? Guys, please speak up.
Evaporator.
It's moving to evaporator, right? So
Yes.
earlier you guys only said that in evaporator coil that so and so is the temperature and pressure. So after moving from the thermostatic expansion valve, what is the temperature and pressure of refrigerant R134A? That is the hint. That is big hint actually.
Don't know about exact value, but it's low temperature and low pressure refrigerant.
Yeah, correct. It's low temperature and low pressure only. So at evaporator coil, you mentioned that the pressure is around 1 bar and the temperature is approximately 4 degrees Celsius for the vegetable compartment, right? So the refrigerant is obviously coming from the thermostatic expansion valve only. There only the sudden drop of pressure and temperature is happening, right? So the pressure and temperature at thermostatic expansion valve and evaporator coil is same, guys. If you follow, if you guys can, I will just share the diagram of. Just a second, I will share the diagram. Mm, just a second, guys. Just a second, guys. I will share. Yeah, is this visible, guys?
No, not visible.
Just a second. Is it visible now?
Yeah.
Yeah. Okay.
Yes,
So
yes.
just a second, guys. Yeah. So as you guys can see here, the liquid or the mixture of refrigerant after coming from the thermostatic expansion valve, it is moving to the evaporator, right? So the temperature and pressure at the thermostatic expansion valve at the evaporator, it is same, guys, because it has come from the evaporator only. In evaporator there is no drop of temperature and there is no drop of pressure. Okay, the pressure remains same there. It is just absorbing the heat from the surrounding. There the liquid vapor is converting into liquid refrigerant is converted into vapor form of refrigerant. Okay, so as it moves gradually towards the top of the evaporator coil, the mixture of refrigerant is now converted into 100% of vapor, right? So basically the pressure and temperature are same at the thermostatic expansion valve and at the evaporator coil. So is it clear, guys, or is there any doubt? Yeah, okay. So, is it clear about all the temperature and pressures at all sides like evaporator, compressor, condenser? or should I explain again?
Just explain as per the components, how it is the temperature as per the components.
Yeah, okay. So first let us begin with the evaporator coil. Okay, so this is the main question the interviewer asked: what is the temperature and pressure at evaporator coil? Rest all are the for backup. He might ask or he might not ask. So most commonly asked question is what is the temperature and pressure at evaporator coil? Okay, so when you are answering this question, so basically you need to answer like, sir, the temperature and pressure of the evaporator coil completely depends on the type of refrigerant we are using. So nowadays the commonly used refrigerant is R134A. So that is tetrafluoroethane, right? So for tetrafluoroethane at evaporator coil, the temperature for freezer compartment is around minus 18 degrees Celsius to minus 20 degrees Celsius at the pressure of 1 bar. And at vegetable compartment, it is pressure at 1 bar and temperature is approximate 4 degrees Celsius, right? And when you move to compressor, the pressure is around 10 bars and the temperature is around 50 degrees Celsius. It is not the exact answer, it is around approximate values. And at the condenser, the pressure is 10 bars and the temperature is around 38 degrees Celsius. Because after passing from the compressor, there is a slightly drop in temperature of the refrigerant, whereas the pressure remains constant. That is the isobaric process. Okay, and after moving from the compressor, it goes to the thermostatic expansion valve, where there is a sudden drop of temperature and pressure due to thermostatic expansion valve acts as an orifice. Okay, so that's why the temperature and pressure of R134A at thermostatic expansion valve is around 1 bar pressure and temperature is around 4 degrees Celsius. Okay, so is this clear or is there any doubt in this? Guys, please speak. Actually, I'm not getting if you are getting it or not. At least give a thumbs up. Okay. So is everybody listening here? G2, Neeraj, or Mazin?
Yeah.
Yeah. Okay. So please speak in between because I'm not getting if you are getting it or not. Okay. Yeah. So shall
Yes,
we
yes,
move forward or is there any doubt here?
yes, yes.
Okay. So the next question is about the VCRS safeties. Can anyone say what are the safeties in refrigeration? What are the VCRS safeties? Anyone? You guys can refer the diagram. Actually, it is written there. Yeah. Raviraj.
First one is the low pressure cutout.
Okay.
After that, high pressure cutout.
Yeah.
After that, the low lube oil pressure cutout,
Okay.
relief valve,
Hmm.
solenoid valve,
Okay.
and oil heater.
Oil heater.
These are, yes, oil heater.
Yeah. Okay. So can you explain them serially? What is the function of them?
The just one second. Low pressure cutout. This is the compressor safety, which is used for the suction side of the compressor,
Okay.
which operates when the temperature in evaporator is achieved, which we required.
Yes.
Okay, and the suction pressure, which is reached below the set pressure, then
Okay.
the low pressure cutout safety operates.
Okay.
Am I right?
Yeah. Please go ahead.
After that, high pressure cutout.
Hmm.
This safety also used for the compressor. When the discharge side pressure reaches above the desired pressure, which we required, then this safety will operate, activate. After that, low lube oil pressure cutout. We know that compressor, there are the rotary parts.
Hmm.
So these rotary parts required lubrication. So we use lubrication oil, and its pressure usually is set at the 2 bar. If the oil pressure will below the 2 bar, then the low pressure lube oil cutout safety uh, operates.
Okay.
After that, the relief valve. We know that the relief valve function, it relieves the excessive pressure which generated by the compressor.
Okay.
After that, solenoid valve, it is fitted on the discharge line of the condenser,
Hmm.
which close when the compressor stopped and tripped to avoid the overflow of refrigerant to enter in the evaporator.
Yeah.
And after that, oil heater. Oil
Okay.
heater is provided for the compressor crankcase oil to prevent the compressor from getting cold, excessively cold.
Hmm.
So these are the safeties we use in compressor.
Okay. So you guys can see there in diagram. There is a pressure gauge at section side and a pressure gauge at discharge side. Are those not considered as a safeties? Is it considered as a safety or not? Anyone?
Is it mountings?
Yeah, it's mounting only. LP cutout, HP cutout, those are also mountings only. Those are the components. So, is it lies under safety or not? The pressure gauge at discharge side and the pressure gauge at suction side. Those comes
I
under
think
safety devices or not?
these are not safety because of this showing only the pressure but not cut out the compressor.
Okay. Yeah, correct. Those does not come under safety devices because those are only showing the pressure at the suction side and the pressure at the discharge side, right? So those are not helping in cutting in and cutting out, right? Those are just showing the indicating the pressure, right? So that does not come
Yeah, yeah.
under the safety devices. So guys, this was the question asked by the Braganza sir to one of the student, and actually he failed here. So that's why I am highlighting this question. So please note that pressure gauge at discharge side and pressure gauge at suction side does not fall under safety devices. Okay, because it just shows the pressure at suction and discharge. Right. So yeah, is there anyone who wants to add some more points to what Raviraj said, or wants to explain it in a different way? Anyone? Neeraj, Jitu, Nazil. Okay, no one. So shall I continue? Okay. So basically, guys, when it comes to safeties of refrigeration system, first one is the low pressure cutout, and second one is the high pressure cutout. Third one is the low lube oil pressure cutout. Fourth one is relief valve. Fifth one is oil heater, and another one is the solenoid valve. Okay, so these are the safeties of VCRS system. So let us understand one by one what are the functions of all those. Yeah, just a second, please. Yeah. So let us understand one by one what are the function of all the safeties. Okay. So yeah, welcome Gulshan. So low pressure cutout, Gulshan. Do you want to say something about safeties of VCRS? Okay. Guys, low pressure cutout is actually a cutout and cut-in device, which acts as a switch on and off device. But whereas high pressure cutouts only acts as an off device, that is only cutout. There is no cut-in. Okay. So low pressure cutout is fixed at the suction side of the compressor. Okay. So the role of low pressure cutout is to cut out when there is a low pressure at the suction side of the compressor. Okay. So why there is a low pressure at the suction side of the compressor? Why the low pressures are achieved? So that the low pressure is cutting out, and it is actually a compressor safety device. Okay, it is for the compressor to prevent the damage for compressor. The low pressure cutout is used. So what are the factors affecting the low pressure? actually low pressures occur when the cooling effect is completely taking place or when the desired temperature is achieved. Okay. Say if you want minus 18 to minus 20 degrees Celsius at fish room or freezer compartment, so the minus 18 to minus 20 degrees Celsius is already achieved there. Okay. So there is no meaning in running the cycle again and flow of refrigerant continuously takes place. There is no meaning. Okay. So at that time, when the temperature is achieved, there is a low pressure in the evaporator coil and there is a low pressure in the flow of refrigerant. That's why it senses and it cuts down the compressor. Okay, the compressor stops when it achieves the desired temperature. That's why the low pressure cutout is used, and it is fixed at the suction side of the compressor. And again, when there is a drop in temperature or when the desired temperature is dropping, suppose if minus 18 degrees Celsius comes to minus 16, minus 15, and again the low pressure cutout comes into the picture, it gets cut in. That means it switches on the compressor. Okay, and this cycle again repeats. Here, the low pressure cutout is acting as cut in and cut out, on and off. The process is happening automatically. There is no manual process. Okay. So next comes the high pressure cutout. I hope there is no doubt in low pressure cutout. Is there anyone who has any doubt in low pressure cutout? Okay. Should I continue with high
No,
pressure?
bro.
Akshay bro,
Yeah.
hello.
Yeah. Yeah. Gulshan.
Are you recording or not?
Yeah. I am recording it.
So please share the all the recorded video and group after finish the that's what class. Okay.
Actually, Gulshan.
Screen recording is on or not?
Yeah. Now recording is on. But the instructions are to first share it in the YouTube. GAN will share it in the group. I am not allowed to share directly into the group.
Okay. But it will take a time now.
Yeah, it will take time. Previous videos are all uploaded in the group. You can
I am asking to you because na I am not joining. मतलब particularly all the guys are not joining. Okay.
Hmm.
And if you are directly after finish the that session, you can update. I upload it on WhatsApp everything whenever you want. So it is very helpful for us, na.
Yeah, yeah, right. Actually, I am uploading it, guys. All the previous videos are uploaded. You can see in the group.
Okay.
But it is taking one day
Okay.
time
But
because the video length is more, right? It is up to
yes,
270
very
pieces.
large now.
Very large videos, so it's taking time to upload. So after
No
uploading,
problem because na guys, it's I only for myself because I am not attending your session. It started.
yeah, yeah, yeah. After uploading, actually,
Yeah. Okay.
GAN is again revisiting the videos and editing the description and all. So the editing team is working there. Yeah, so
No
it's
issue.
taking time. If you want it,
You can
I
continue.
can share it to you in Telegram. You can message me. I will directly share you the video.
Yeah. Okay. Of course. You can share with me. I am hello. Okay. I say hello on your Telegram. Okay.
Yeah, sure, sure. Okay. So should we
Okay.
continue
You
now?
can continue.
Yeah. Is there any doubt
Okay.
in low pressure cutout, guys? Is there any doubt in low pressure cutout or is it clear?
Can you tell me low pressure cutout is any device or what?
It is a safety device.
Okay, it is a safety device now.
Yeah, it is a safety device for
Can you
VCRS.
tell me in short words how it's work?
Yeah. Actually, low pressure cutout works when there is a low pressure at the suction side of the compressor. Okay.
Okay.
How? Why there is a low pressure at the suction side of the compressor? Why not high pressure? Or what are the factors that are affecting the low pressure at the suction side? I will tell you. Okay. So basically, before the suction side is a evaporator coil, right? So the function
Okay.
of the evaporator coil is to give the freezing effect. That is the
Facing
component.
effect now.
Yeah, that is the component where the cooling effect is taking place or the refrigeration effect is taking place. Okay. So when the set temperature, say for freezing compartment, the temperature is around minus 18 to minus 20 degrees Celsius, right? So when the temperature is
Okay.
already achieved, there is no need
Hmm.
of compressor to run again. Okay. So at that time, when the
Okay.
set temperature is already achieved, the low pressure is happening at the suction side of the compressor. So this is sensed
Okay.
by the low pressure cutout, and it cuts down the power supply to the compressor, and the compressor is switched off. Okay. So it
Okay.
is acting both as a cut-in and cut-out. Okay. What is the meaning of cut-in and
Okay.
cut-out? Cut-in is switching on. Cut-out is switching off.
Okay.
Okay.
Cutting is switching on.
Yeah. Cut-in.
Okay.
Cut-in is switching on. Cut-off. Cut-out is
Okay.
switching off. Okay. So when there is a low
Okay.
pressure, the cutout takes place. In the sense,
Okay.
it switches off the compressor. There is no need to run compressor because the temperature is already achieved. So up
Okay.
till when the temperature remains there, the compressor is switched off. And once there is a drop in temperature, say minus 18, it comes to minus 15, minus 10, and again there is a high pressure. Okay, the cut-in
Okay.
at that time the low pressure cut-in takes place. Cut-in means it switches on the compressor automatically. That is not a manual process. That is an automatic process. It switches on the
Okay.
compressor again, and again the cycle takes place, and again the cooling effect is taking place. So this is the work of the low pressure cutout.
Okay. That means, can I watch on YouTube with the help of animated video? It's very helpful for us, no?
Yeah, you can watch it. Actually, I would have shared it, but it makes the session very lengthy. Actually, I am interested. Actually, I am being instructed to make the video up to 45 minutes and not more than that. So my session is going up to 55 and 58 minutes.
Your voice is lagging, I think.
Hello, am I audible now?
Yeah. Yeah. Audible.
Yeah. So I have been instructed to make the session short. If you want the animated videos, guys, you can personally watch it in the YouTube. Okay.
Yeah.
So
Yeah. Yeah. No
if
issue. No.
I share it here, the session goes long. Okay.
Okay. Okay.
So next is the high pressure cutout. Okay. So is there any doubt in the low pressure cutout? No. Okay.
Go ahead.
Yeah.
It's okay. Yeah.
Yeah. So let us continue with the high pressure cutout. So high pressure cutout is also the safety device which is fixed at the discharge side of the compressor. Okay. So what is the work of the high pressure cutout, guys? As the word says, whenever there is a high pressure than the set pressure or the designed pressure, the high pressure cutout takes place. It cuts off the compressor and stops the compressor. It is also the safety device for the compressor. Okay, whenever there is a high pressure, uh, why do you think the high pressure takes place, guys? What are the factors affecting the high pressures? As I said, what are the factors affecting the low pressure? That is when the cooling effect is taking place and when the temperature has been achieved already. At that time, the low pressure is taking place. So, what is the reason for high pressure? Anyone? Any guess?
I think to restart the cycle again.
Yeah, to restart this cycle again. No, I am asking why high pressure takes place in the cycle. What are the factors that are causing high pressures inside the cycle? Any guess? Anyone? Okay, should I tell?
Yeah.
So basically, why high pressure is taking place? Because there might be some dust particles stuck inside the cycle or the flow. There might be some dust particles stuck inside the flow. That's why the flow of refrigerant is not proper and causing the high pressure. And there might be improper lubrications and frictions inside the crankcase of the compressor. Due to the wear and tear, the temperature increases, and as you all guys know, as the temperature increases, the pressure also increases, right? Am I right or wrong? Guys, please speak up, guys. Okay. So this is why the high pressures take place, and when the high pressure is taking place, the high pressure cutout comes in. High pressure is the only cutout. There is no cutting in the high pressure. Okay. When the high pressure cutouts take place, the compressor is switched off, and we need to manually turn on the compressor when the high pressure cutoff takes place. It is not automatic. Can you guys tell why it is not automatic? Anyone? We have to switch on the manually compressor. Why is it not automatic? We would have made it automatic, right? Why is it not automatic? Anyone? Okay, I will tell you. So basically, why it is not automatic? Because we need to switch on it manually, because we are attending the problem there. We need to understand why there is high pressure. Okay, we need to solve that problem. Now there is an indication that there is a high pressure. We know there is a high pressure. Okay, so now we need to do the inspection why there is a high pressure. After finding out the problem, we need to start the compressor. Okay, or else if we start the compressor without attending the problem or without knowing anything, then again the high pressure cutoffs take place and again the compressor is going to switch off. Okay, so this is why to attend the problem, to understand why exactly the high pressure is taking place, the high pressure cutout is only one way, that is only cutout is taking place, there is no cut in. Are you guys understanding? Is it clear?
Yes, yes, yes. Got it.
Yeah. Okay. So next one is low lube oil pressure cutoff. So as the word is saying, low lube oil pressure cutoff. So there is a lube oil flow in the crankcase of the compressor. Okay, to keep it lubricating, to avoid the friction and to avoid the friction losses and temperature. Okay, so there is a set lube oil pressure inside the compressor. If it falls below the set limit, then the lube oil pressure cutout takes place and the compressor is stopped. And again, it regulates the flow of lube oil at the set pressure, and it turns on the compressor. So that is where the lube oil pressure cutout is used, and that is the function of lube oil pressure cutout. So is there any doubt in lube oil pressure cutout? Anybody?
So I have one question.
Yeah.
Uh, for to increase the pressure in the compressor
Yes.
uh, for lubrication, so which there is a any pump use or there is a splash lubrication?
Actually, I think pump is used there, because if it was a splash lubrication, then there was no use of low pressure cutout and high pressure cutout. Sorry,
Yes, yes.
low lube oil pressure cutout, right?
Yeah, yeah, right.
If it was a splash lubrication, then there is no meaning in putting that low lube oil pressure cutout. Anyways, it is happening because of splash lubrication only, na?
Yeah, yeah.
Yeah. So obviously, there is a pump inside, or there is a device which is regulating the flow of lube oil. Obviously, it might be used, na?
Yes, yes. Got it.
Yeah. So is there any other doubt, guys, in this low lube oil pressure cutout? Okay. So let us move to the relief valve now. I think all of you guys know what is the function of relief valve. Can anybody explain why relief valve is used in reverse system and where it is fixed? Anyone? Okay. So basically, guys, relief valve is used to release the excess pressure when there is a high pressure in the compressor. It is used to release the excess pressure, and it is fixed at the discharge side of the compressor. That is also a safety device for the compressor only. High pressure cutout is safety device for compressor. Low pressure cutout is a safety device for compressor, and a low pressure cutout is also for a compressor only. And relief valve is also for the compressor only. Basically, all the safeties are for compressor only. Okay. So, is it clear, or is there any doubt in relief valve?
Bro, I have one question.
Okay.
We use high pressure cutout,
Yeah. Right.
right? So why we required relief valve there? Already
Yeah.
compressor is shut down na, when high pressure cutout safety operates.
Right. Right.
Then why we use relief valve?
Right, exactly. That was also my question. That was also my question. Actually, I was finding answer for that. So I am not exactly sure about this answer, but I can somewhat give you the answer on this. So basically, when there is a high pressure in the compressor, okay, So there is no immediate cutout in the high pressure cutout doesn't act immediately according to me. I think I am not sure on this, guys. Please do your own research on this. So let us discuss in this in the group also. So the high pressure cutout doesn't act immediately. Some of the high pressure is transferred towards the condenser. Okay, so that's
Okay.
why to prevent the condenser from damage, the relief valve is releasing the excess pressure and sending the limited pressure or set pressure to the condenser. So this is the reason I think. So
Yes,
what do you
yes.
guys say on this? Is it right or is it wrong?
I think there is a right answer.
Yeah,
Yes.
I actually, literally, guys, I am not sure on this, but this is my guest answer. So let us discuss in the group. So let us
Yes, yes.
get some more answers. So I will put the question in the group. Okay. So you
Okay.
also can share the question in the group. Okay. Yeah. So shall we move forward?
Yes, yes.
Yeah. Next one is the oil heater, guys. What is the function of oil heater? Why is it used in the refer system as a safety device? Anyone?
I think there is chances not to compressor getting a cold because of the low temperature of refrigerant, which is continuously flowing through the refrigerator.
Yeah, there is some amount of heat transfer taking inside the compressor as well because of low temperature and low pressure of refrigerant coming inside the compressor. So there might be chances of lube oil getting cooled, and as the lube oil gets cooled, its viscosity increases, right? And as the viscosity increases, you all guys know that there is flow resistance. Okay, due to this flow resistance, the crankcase is continuously going into the friction and wear and tear. Okay, so to avoid this, the lube oil needs to be heated to smoothly flow it into the crankcase, right? So that's why the oil heater is used as a safety device inside the compressor. It is fixed inside the compressor. Okay, is it clear, guys? Yeah. Okay. So actually, these are the five safety devices which are used into the VCRS or the refer system. So there is another safety device. That is the solenoid valve. Solenoid valve is not most commonly asked question, or they are not even expecting to mention the solenoid valve. If they are expecting some more, then you can mention solenoid valve. Okay. So basically, guys, solenoid valve is a valve which is fixed uh, at the condenser, at the discharge side of the condenser. Okay. So why is it used, guys, solenoid valve? Actually, it is the electronically controlled valve. Okay, which works on the principle of hydrodynamic pressure. Okay, so when there is a high pressure, okay, in the compressor, and there is a high pressure cutout works and the compressor stops, right? Obviously, when the compressor stops, there is no need of refrigerant to flow to the thermostatic expansion valve. As the
Right.
high pressure cutout is working and the condenser stops, this solenoid valve is closing completely and restricting the flow of refrigerant to the dryer and the thermostatic expansion valve. Okay, so that's why the solenoid valve is used. Okay, is it clear, guys? So this is all about the safeties of VCRS. These are the six safeties which we discussed today. So actually, there are a few more questions which we had to discuss today. So it will make the session more lengthy, I think. So it will be good if we discuss those questions tomorrow, because those are only 2 or 3 line answers. It can be answered in within 2 minutes or 3 minutes. So this was the important session on temperature and pressure of refrigerant and the safeties of refrigerant. I think this is enough for today. So is there any doubt on this, guys? So what we have discussed today up to this, is there any doubt? Anyone?
No. So
Okay.
I have one question.
Yeah, yeah. Go ahead.
Uh, now you explain the as per the R134A refrigerant.
Yeah.
what is the temperature in evaporator, compressor, condenser?
Yeah, correct.
Okay. So, do you have any notes about other refrigerants?
Look, actually, in marine field nowadays, we are using R134 refrigerant only. So
Okay. Okay.
all the explanation is with respect to R134 only. So these are the approximate temperature and pressures are with respect to R134 only. So the interviewer is expecting this only. He is not
Okay.
expecting for any other refrigerant. Okay. So the important key here is that you mention that it depends on the type of refrigerant used. And nowadays, the most commonly used refrigerant is R134A, that is tetrafluoroethane. You need to mention this. After mentioning this, you need to go for temperature and pressure. Okay.
Yeah. Yeah.
Yeah. So basically,
Got
nowadays R134A is only used. So in future, if the refrigerant is replaced, then you need to explain according to that. So for now, the explanation is stick to the R134A only. Okay. Yeah. So is there any doubt about today's session? Anybody? Okay. Guys, actually, I wanted a feedback from you guys. So, this is my first time I'm conducting these sessions. This is not my first session. This is my fourth session. But before or earlier, I have never attended any sessions or I have never conducted any sessions. Okay. So I wanted a feedback from you guys. Is there any improvement that has to be implemented from my side? Or do I need to change some procedures or something from my side? Or is there anything or any area in which I need to improve? I want feedback from you guys. Is there anything? If there is nothing,
I
you guys can say. If there is anything, you guys can say. No problem.
think you explained very well.
Yeah, okay. Thank you so much. So,
Yes, sir, you are giving in the correct way. So we are okay with it.
Continue, brother. Continue.
Continue, sir. Continue, sir.
thank you, thank you. So that's it, guys. Shall we end up the discussion today?
Yes. Yes.
Yeah, okay. So that's it for today, guys. Bye. Take care. You guys can.